All right, so thank you all for coming. Today we're going to be talking about robot-robot communication with wallabies. I'm Tobin's Latest.
And I'm Annalise Kellier, and we're from the Fox Singing Team 0314. In this presentation, we will explain how to connect your wallabies, send data between them, and utilize this on the competition field.
All right, so why would we want to communicate between our two wallabies? So for this year's challenge, they limited the amount of cameras in the kit to one camera. So particularly for sorting objects in the colored zones at the back of the field, we needed a way to expand our strategy so that we can have the camera on one robot and communicate that data to the other robot.
So we did a whole bunch of research on this, and we discovered that there was not too much information out there on how to connect the wallabies easily. And so we decided that if we could get them to connect, we would try to share this information. So during our research, thank you, by the way, to the Dead Robot Society and the Los Altos community teams for advice and encouragement, we concluded that using Wi-Fi to connect the two wallabies would be the simplest way, because other methods such as Bluetooth would require like physical hardware modifications to the wallaby, like an antenna or some other method. And so this, because it is already built into the wallaby, would be the easiest method. During trial and error, we developed the following method.
Okay, so the first step in our process of getting the two wallabies connected was to establish one of the wallabies as a client and one as the host. So this is similar to when you're programming your wallaby over the web IDE, your computer would be the client.
Yeah, so in this step, basically our wallabies were not connected to the robot at this point, and so we just changed the background color of both wallabies so we could tell them apart, and that way we just decided one is the client and one is the host. And the host does not need any modifications with hardware or software, because your wallabies are already acting as hosts when your computer is acting as the client and connecting to them to download code. And so all we needed to do was configure the client so that it would be able to connect to the host and begin to communicate.
Okay, so for the second step, we needed to open up a Linux terminal. So I use a Mac, which is Unix-based, so I already had a terminal installed, and then Anna's going to talk about her experience with Windows.
Yeah, so the wallabies run on background Linux, and so my Windows computer does not, and so you have to download your own Linux terminal. And so howtogeek.com has a great tutorial on how to download your own terminal. So I got an Ubuntu terminal, and we were able to use that to connect to the wallabies.
Okay, so step 3 was to connect to the wallaby with your computer to the wallaby. So we did this over the USB interface using a micro USB cable. This is because later on we're going to be messing around with the Wi-Fi signal. This is the only way you can keep a consistent communications channel.
So in the computer terminal, we type SSH root at 192.168.124.1, and this is the IP address that your USB cord uses, so that when you're opening up your web IDE and you're connecting it to the wallaby, this is also the IP address that you would use. And so this lets the computer connect to the wallaby, and then you can execute commands just like you're the wallaby. And this is another way that you could do this is connect a USB keyboard to the wallaby and open up the terminal instead. But because the wallaby screen is so tiny and fussy, we just use SSH to SSH into the wallaby. That way we can execute commands without all the hassle.
All right, so now that we're on the wallaby, we're going to use a tool that was pre-installed in the Linux distribution. So this is the WPA passphrase tool. So we're going to provide it with the SSID of the host wallaby and the password, and that will save it to a configuration file.
And so we can just find the host's SSID and the password in the about page of any wallaby. And so you just take that from the host, and then WPA passphrase will package it up, and that way the client wallaby can use it to sort of bounce off the host and verify that it has the correct SSID and password, and that will allow it to establish a connection.
All right, so for the next step, we went into the wallaby again and we created a script. So that's an executable file containing the important connection commands we needed.
So in the file, we had all the commands that we were going to need to connect the two wallabies. The first of these is kill all host APD, which removes the client's any of the client's prior connections and turns off the hotspot function, because if the client is also broadcasting out its own Wi-Fi, it will not be able to connect to your host Wallaby, and so this interferes with everything. And so kill all host APD removes all of the client's connections. And then the next command we used was WPA supplicant, which takes that box with the SSID and password that created in the last step, and it sort of gives it to the host, makes sure that SSID and password match, and then that establishes the connection and allows it to begin.
Okay, for step number 6, we went into the KISS IDE and we wrote a C program that would execute our script. So the first thing we did was cd, which is the change directory command. So this would change to the home directory of the root user. And then we did /start.sh, which was the name of our script that we created earlier. After that, we needed a way to get an IP address on our client Wallaby. So using DHCP, we released the current IP address, which would be a .1 if it were a host. And then we asked, again with DHCP, the host Wallaby to provide us with an IP address, which would be .2.
So now we're going to explain some of our basic troubleshooting methods.
Okay, so for this, we basically utilized the networking tool ping, so we could bounce ICMP packets between the host and the client.
And then the other basic troubleshooting methods that we used were basically just if it's taking too long, you want to shut everything off and start it up again. And also because the Wallaby takes a little time to like open up its network, whenever it's saying like welcome and it turns on the blue light, sometimes it would do this in the middle of the program, which would mess everything up. And so you want to make sure to wait for the Wallaby to turn on its light and say welcome before you run this program. Another way that you can tell that they're connected is the host. If you look in the networking information on your Wallaby, the host will have a .1 and the client should change its IP address to .2. So practical applications for this would be, we were thinking in the beginning with having our two Wallabies share, or the game object positions, like the zone colored cubes, between the robots that they could both sort objects. Robot coordination and pathing. If one robot wants to wait for the other one to pass, you can send a message that it's done and it can go along. Robots can share sensor input, and also we were thinking one of our ideas that we were hoping to implement eventually is have a robot with a camera watch the other robot to give feedback on positioning or whether it succeeded in a task. And so if we could have one of our robots watch the other one pick up Hawkeye, for instance, it could tell if like Hawkeye was successful or if the other robot needs to try to pick it up again.
Okay, so some recommendations we have for those who want to try it. We found to write, or using SCP, which was touched on in the earlier presentation, was our most reliable method. And then there are a few issues we had with the connection when it would drop out. Sometimes the wireless interface will become a loopback interface, so it will appear that it's connected to the other Wallaby. Well, it's actually not.
Yeah, so we found that the best method, the ways we tested to send data between the Wallabies, was just to take the data, such as the camera values or sensor input or anything, and then write this to a text file, and then use SCP to send this to the other Wallaby, and then that Wallaby can open up that file and then make decisions based on what it finds inside the file. Yeah, now you can ask any questions, or email us at info@.
We have time for like 2 or 3 questions if anybody have other ones.
Have you guys considered WebSockets?
We did try WebSockets. We had a lot of difficulties just getting that up, and so because we were pretty novice at this, we decided that we were going to go for a simpler route. Even though it might not be as efficient in the end, we could get it working before the competition, and we wanted something that could be fast and easier to troubleshoot than sockets, in our opinion. Yes?
So I was curious, you mentioned loopback and mimicking or working connections. When our team was researching this, we found a lot of undocumented behavior. And I'm curious, like, what exactly did that look like, the loopback? Because that might be something that we encountered as well and just never realized.
So in that scenario, we had an issue when we were pinging from the client to the host. It would appear to be working, but when we would ping from the host to the client, the static route over that interface, it would just refuse the connection.
without having time to like thoroughly test this, we didn't notice too much delay. Like in his paper, he said that he had seen 6-second delay. We didn't see anything like that long, maybe a second or so with our method.
Okay, we have time for one more question.
Involves like using a Linux terminal. Is it possible to like use it like on a virtual machine that's running on Linux?
I'm sorry, you're asking if you can open a terminal on any Linux machine?
Any Linux operating system that has the terminal and it's running on a virtual machine.
Yes, so you can use virtual machine, you just want to make sure that if you're connecting the Wallby to your